Hello again. We're going to be solving linear systems by graphing. And you can solve linear systems with not just graphing, but also by elimination and substitution. But what we're going to do right now is solve them by graphing. And you've already done this before if you're following through with the lessons. What we've done is we've graphed a line. Well, this time what we're going to do is graph a system. And basically a system means two or more equations, and we're going to see where they cross. So we're going to graph these two equations, and the answer, where they intersect or where they cross, is going to be the solution of the system. Now, if you want to graph these problems, the first thing you should do is solve for y in both of them. And I went ahead and gave you an example of two problems. So we're going to solve for y in the first one, and we're going to solve for y in the second one. Now, if you want to solve for y in the first problem, x plus y equals 3, subtract x on both sides. And what you get is you get y equals, and put the x before you put the number, negative x plus 3. And you can't combine them because x is a variable and 3 is just a number. They're not like terms. So we've solved for y in the first one. Now we're going to solve for y in the next one. X minus y equals 1. So I'm going to go ahead and write an arrow that goes down there so you can see that. X subtract y equals 1. There's a few ways to do this, but I'm going to say just subtract x on both sides. And what you get is negative y equals negative x plus 1. But we're not solving for negative y here, we're solving for positive y. That actually reads negative 1 times y. So in order to get rid of the negative 1 times the y, you have to divide by negative 1. But what you do on one side, you do on the other side. So I'm also going to divide this side by negative 1. Well, the negative 1's cancel, and I'm left with y equals, now, negative x divided by negative 1 is just x, and 1 divided by negative 1 is negative 1. So I've got both my problems here. What I want to do now is create myself a Cartesian plot system or XY axis, whatever you want to call it. And usually when I tell my students to do this, I say, go ahead and make something, and they ask me, how many dashes do I need on each mark? How many marks do I need on each axis? I say, start with 5. If you need more, add more. If you don't need more, then you're fine. So I'm going to graph this one in red, and I'm going to start with its y-intercept, which is at 3. 1, 2, 3. And then from the y-intercept, you make sure you take care of your slope, which is negative 1 over 1. So down 1 over 1. Let's do it a few more times too. Down 1 over 1 over 1. And I like to tell my students that because sometimes when you're graphing these two equations, or when you're graphing a linear system, they don't just intersect at the first point you want them to. So sometimes you have to plot points that go downwards and plot points that go upwards, pardon me. And I'm going to graph this one in, let's make it blue. The y-intercept is at negative 1, and then my slope is 1 over 1. Now, if I only plotted 2 points here, I couldn't see where they connect. My dots haven't, or my points on both graphs haven't yet connected. So keep going. You go up 1 over 1, you can keep going, up 1 over 1. That's where they're going to intersect at. They're going to intersect at 2, comma 1. Now I don't tell my students to leave it like that. After you've made your points, go ahead and create a line for both of them. Those are actually pretty good lines. That's what a linear system is when you're solving for it. You've got two equations. Go ahead and solve for y if you can. Sometimes you're not going to have a y value to solve for, but most of the time you will. Plot them and see where they intersect. Where they intersect is called the solution of the system. And it only crosses one time, so there's only one solution. Now most of the problems that you do in a linear system of two equations will cross once. Sometimes they won't cross at all, and sometimes they will always cross. On the next lesson I'll explain the special cases. But we're going to finish this part up, and we're not quite done yet. So the solution is at 2, 1. Now students might ask, well, how do I know the solution's at 2, 1? What you do is you substitute it back into both equations. Now you can do it from the originals or from the modified ones that you solve for y. It doesn't matter which one, to see if they ring true. Now we're going to do it from the original ones. X plus y equals 3 and x minus y equals 3. I might have said 3, I meant 1 there. So when I substitute them in, my x value is 2 and my y value is 1. 2 plus 1 is equal to 3. 2 subtract 1 is equal to 1. So that story checks out. That proves that it's a solution. Now, students say, well, what's the use of that? Why did you go ahead and tell me that? Well, let's pick a point that you know is not going to be a solution, where you know it's not going to cross for sure. And the easiest point that you can substitute in to see if it's not a solution or it is a solution is 0, 0. So I'm going to go ahead and substitute in 0, 0 into these two equations. Now, if you want to check to see if it works, it has to work for both of them. It can't just work for one, it has to work for both. So if I substitute in 0, 0, well, 0 plus 0, it's garbage. It's not equal to 3. If it works for one of them, but it doesn't work for the other, it's not a solution. It has to work for both. Now, the way for you to understand that is by graphing it so that you can get a pictorial representation in your head. But later on, not much later on, mind you, I'm going to show you ways to find a solution of a linear system without even graphing in itself. And it's kind of based off of this part right here, and I'll kind of tie that in. But for right now, we're going to focus on the graph. So as you can see, solve for y for both of them. Find out where they intersect by creating many points for each line. And where those two lines intersect, or where that system intersects, is called a solution. Test the solution in both equations, and if it rings true, that's the solution. Now in this case, there's only one solution. You have to think about it visually. If you have two lines, how many times do you think they're going to cross? Well, they can cross one time, or they might never cross. Something else altogether. But we'll get to that in the next lesson. But for right now, have a great day. Goodbye.